If you are putting an AI agent into a real workflow, you need more than a launch button. Most teams think about how to start an AI agent. They think about prompts, tools, automations, dashboards, and output quality, but they do not spend enough time thinking about how to stop the agent safely. That is dangerous because when an agent fails, you do not want your only options to be keep running or delete everything. You need a break. You need a way to pause actions, reduce permissions, preserve evidence, and keep the useful parts of the workflow alive while you investigate. That is what an agent kill switch is for. And in this video, I want to show you what that actually means in practical terms. A kill switch is not just turning off the model. That might be one option, but is usually too blunt. A useful kill switch controls the agent's authority. Can the agent call tools? Can it write to external systems? Can it send messages? Can it create tickets? Can it change priority, close a task, update a record, or trigger an action? The kill switch should let you control those powers separately, because sometimes you do not need to shut the whole system down. You just need to stop the risky part. If the agent is summarizing information correctly, but making unsafe changes, keep the summaries and freeze the changes. If the agent is useful in read-only mode, keep it read-only while you investigate. If the agent is producing questionable recommendations, quarantine the recommendations before they reach downstream systems. The goal is not panic. The goal is controlled degradation. A simple way to design this is with 4 modes. Mode 1 is live mode. The agent can perform approved actions inside its normal boundaries. Mode 2 is assisted mode. The agent can still reason, draft, summarize, and recommend, but a human must approve high-impact actions. Mode 3 is read-only mode. The agent can inspect data and produce analysis, but it cannot write, send, update, delete, or trigger external actions. Mode 4 is paused mode. The agent stops processing new work, except maybe health checks and trace export. These modes matter because failures are not all the same. A minor output quality issue might only require assisted mode. A tool permission issue might require read-only mode. A boundary violation might require paused mode. The mistake is treating every incident like a total shutdown, or worse, treating every incident like nothing happened. The first control layer is tool permissions. Every tool the agent can call should have a risk level. Read-only lookup is different from sending an email. Drafting a ticket is different from closing a ticket. Fetching a vulnerability context is different from changing vulnerability priority. A good kill switch can disable tool categories quickly. For example, you might keep search, retrieval, and summarization enabled, but disable updates, sends, deletes, payments, deployments, or anything that touches production state. This is where many agent systems are too loose. They give the agent a large tool belt and then hope the prompt keeps everything safe. That is not enough. Prompts are not permission systems. The kill switch should live outside the prompt. It should be enforced by configuration, policy, workflow routing, or tool wrappers. The second control layer is approval gates. Some actions should never be fully autonomous unless the system has earned that trust. Approvals are not a sign that the agent is weak. Approvals are how you keep accountability in the workflow. A kill switch should be able to raise approval requirements instantly. Maybe the agent normally creates tickets automatically, but during an incident, every ticket goes to review. Maybe it normally updates priority, but after a bad recommendation, priority changes require a human. Maybe it normally sends a notification, but after a boundary event, all outbound messages become drafts. That is assisted mode. The agent still helps, it just stops acting alone. The third control layer is output quarantine. This is especially important when the agent feeds another system. If the agent writes directly into a ticketing system, CRM, inbox dashboard, or codebase, bad output can spread quickly. A quarantine layer creates a holding area. The agent can still generate the output, but the output does not become official until it passes review. This is useful when you are not sure whether the agent is wrong in every case or only some cases. Instead of shutting everything down, you'll hold the outputs, inspect a sample, compare against traces, and release only what is safe. That gives you time. And time matters during incident response. The fourth control layer is trace preservation. When you activate a kill switch, you should preserve the evidence. Inputs, context, tool calls, tool responses, policy check, approval decisions, final outputs, errors, timestamps. If the kill switch destroys the trace, you will have a harder time figuring out what happened. So the kill switch should not just stop behavior. It should also freeze the incident record. That record is what lets you classify the failure, measure blast radius, fix the weakest control, and prove the fix worked. No trace means no serious investigation. Now the question is when the kill switch should activate. You can trigger it manually. That should always exist, but you can also define automatic triggers. For example, if the agent attempts a restricted tool, switch to assisted mode. If it crosses an approval boundary, switch to read-only mode. If it produces too many missing evidence outputs, quarantine recommendations. If reviewer overrides spike, require approval for the affected action type. If cost, latency, or retrace suddenly jump, pause new work until you know why. If the agent touches a high risk workflow, require a stronger threshold before live actions resume. The point is not to overreact to every tiny issue. The point is to define what counts as serious before you are in the middle of the incident. Here's a cybersecurity example. Imagine a vulnerability triage agent. It reads scanner findings, checks asset context, looks up exploit intelligence, checks exposure, and recommends priority. One day, a human reviewer notices that the agent marked an externally exposed vulnerability as low priority. That is a serious failure. But the response should not be delete the agent. The response should be controlled. First, switch the agent out of live mode. Second, disable priority changing permissions. Third, keep read-only lookup enabled so the agent can still help gather evidence. Fourth, quarantine all new priority recommendations. Fifth, preserve the traces for affected findings. Sixth, route similar findings to human review. Seventh, patch the required evidence checks. Eighth, retest with cases where exploit intelligence and exposure should change severity. Then relaunch gradually. Shadow mode first, assisted mode next. Limited live mode only after the evidence supports it. That is how a kill switch turns a dangerous failure into a manageable incident. Here is the checklist. Define the operating modes. Live, assisted, only, paused, classify tools by risk, separate read actions from write actions, put high impact actions behind approval gates, create a quarantine path for uncertain outputs. Preserve traces when the switch activates. Define manual activation. Define automatic triggers. Log who activated the switch and why. Make relaunch gradual. And test the kill switch before you need it. Do not wait for a real incident to find out that your pause button does not work. A trustworthy AI agent is not one that never fails. A trustworthy AI agent is one that can fail safely. You can pause it. You can reduce its authority. You can preserve the evidence. You can keep humans in the loop. You can fix the failed control. And you can relaunch carefully. That is production thinking, not just building an agent, operating one.